Hello students, today we are going to discussing what? Periodic properties. Periodic properties discussing in today in class. Remember students, first periodic properties that is called atomic size. Atomic size or atomic radius. Atomic radius. Atomic size is nothing but the distance between the nucleus and outermost electron of an orbital of an atom. It is called atomic radius. Atomic radius is nothing but it is a distance between it is distance between it is a distance between nucleus and outermost orbit of an electron. Outermost orbit of an electron called atomic size. Atomic size. Remember students, atomic size is nothing but the distance between the nucleus and outermost electron of an atom. It is called atomic radius R. Generally, atomic radius is measured, it is measured in angstrom, a power 0. It is measured in angstrom. It is measured in angstrom. 1 angstrom equal to 10 to the power of minus 8 centimeters or 10 to the power of minus 10 meter given. Remember students, generally what? Atomic size or atomic radius, it is measured in terms of angstrom given. 1 angstrom equal 10 to the power of minus 8 centimeters or 10 to the power of minus 10 meters. You know what 1 nanometer equal to 10 to the power of minus 9 meter. 1 picometer equal to 10 to the power of minus 10 meter. 1 femtometer equal to 10 to the power of minus 15 meters. Remember these values students. This is about atomic radius. See, after understanding what the definition of atomic radius, let us discuss about what variation of atomic radius in groups and periods. Variation of atomic radius in groups and period. Already last class discussed, in the long form of periodic table, horizontal lines are called period given, vertical columns are called groups given. There are 7 period and 18 groups given. Now after understanding what the definition of atomic radius, let us discuss about variation of atomic radius. Atomic radius in groups and periods. In groups and periods. Variation of atomic radius in groups and periods. First of all, I am going to discussing in groups. In groups. When we move down the group, atomic radius increases. When we move down the group, atomic radius increases. Atomic radius increase. For example, one group elements I am taking what? Lithium, sodium, potassium, rubidium, cesium, like this. Down the group atomic radius increases. The reason, the principal quantum number n value increases. Now the electron configuration of lithium is here 2s1 writing, 2s1, here 3s1, here 4s1, here 5s1, here 6s1. Down the group what? N value, the principal quantum number increases. N value indicates what here? Size of the atom, size of the atom. N value increases, size of the atom increases down the group. That is why what? Down the group from lithium onwards what? Size is increases. That is why cesium having more size than lithium. So, because of the reason, because of N value increases down the group, down the group. So atomic radius increases. So radius increases. N value increases, so radius increases down the group. Therefore, radius order what? Lithium what? Less than sodium, less than potassium, less than what? Lithium, sodium, potassium and cesium, like that. Rubidium and cesium. The large atomic size of elements in the long form of periodic table, that is cesium. Cesium is a large atomic size of elements. Down the group what? Atomic radius increase because of N value increases. Remember students, atomic radius is nothing but it is a distance between the nucleus and outermost electron of an orbital of an atom. It is called what? Atomic radius. Generally atomic radius is measured in angstrom or nanometer or picometer. Now variation of atomic radius in groups discussing. Generally atomic radius what? Increases down the group because of down the group what? N value increases. Now variation of atomic radius in period discussing now. Variation of atomic radius in period. Now I am discussing what? In period. Generally what? In period from left to right. In period from left to right. From left to right. Atomic radius. Left to right what? Atomic radius decreases. Atomic radius decreases. Reason. The reason from left to right, nuclear charge increases. Nuclear charge increases. Therefore, once nuclear charge increase mean nuclear effect on outermost electron. Nuclear effect on outermost electron. On outermost electron increases. Nuclear effect on outermost electron increase by here. Remember, this nuclear effect on outermost electron increase. When we move down the from left to right in a period, atomic radius decrease giving. Why atomic radius decrease in a period? The reason, whenever I am moving from left to right, nuclear charge increase. Once nuclear charge increase, nuclear effect on outermost electron increase. Therefore, atomic radius decreases. Second periodic property discussing, it is called ionization energy. Ionization energy. What is ionization energy? I am going to discussing. Ionization energy is nothing but energy required to removal of electron, to removal of outermost electron from gaseous isolated neutral atom, from gaseous isolated isolated neutral atom. What is ionization energy giving by? Ionization energy is nothing but energy giving to atom. It remove the electron from isolated gaseous neutral atom. It is called ionization energy. Here one atom is there. Atom contain one electron in outermost which is present in gaseous state. For removal of this electron, some energy giving to atom. The energy required to removal of this outermost electron, this energy is called what? Ionization energy. If nuclear attraction is more, ionization energy more. If nuclear attraction is less, ionization energy what here? Less here. Remember students here, whenever nuclear attraction increase what? The removal of electron is very difficult to what atom, that is why whatever energy required for removal of this electron is more. So, that is why here down the group what? Atomic size increase. Atomic size increases is nothing but nuclear effect on outermost electron is very less. That is why ionization energy in generally down the group what? Down the group decreases ionization energy. Now, variation of ionization energy in groups and periods. Variation of ionization energy. Variation of ionization energy in group and periods. In group and periods. First of all, I am going to discussing in group, in groups. In generally what? In generally what? Ionization energy. Ionization energy what? Decreases down the group. Down the group. Why ionization energy decreases down the group? Reason. The reason down the group what? Atomic size increases. Atomic size what increases? And nuclear effect on outermost electron. On outermost electron what? Decreases. So, ionization energy decreases. Remember students? Generally what? In generally ionization energy decreases down the groups. Those important points you have to remember by enough here. See why ionization energy what decreases in a group? The reason down the group atomic size increases and nuclear effect on outermost electron decreases. So, ionization energy decreases. Say the energy required for removal of electron from outermost orbital of an atom, it is very easy. That is why ionization energy what? Here decrease down the group. Now, I am discussing now in a period. Now, variation of ionization energy in period. In period, ionization energy increase. Ionization energy increase. The reason in a period from left to right. From left to right, atomic size decreases. Atomic size what decreases? Decreases. And nuclear effect on outermost electron. On outermost electron increase. So, ionization energy increases in a period. Remember students. So, this is ionization energy. For example, Now first A group elements I am taking lithium, sodium, potassium, rubidium, cesium given now. Lithium what? Sodium, potassium, rubidium and cesium. Ionization energy already size given, size or radius already given, radius down the group increase radius. Once radius increase mean ionization energy what decreases. Ionization energy for lithium is more, next to sodium, next to potassium, next to rubidium. Remember students, down the group radius increase, along the period radius decreases, and down the group what ionization energy value decreases, along the period generally what ionization energy value increases. So let us discuss about after ionization energy. Ionization energy is nothing but, remember student, energy required for removal of electron from outermost gaseous neutral atom given. That is why ionization energy always positive. Ionization energy is always positive, always positive. Ionization energy is always positive. Let us discuss about now third periodic properties, that is called electron affinity. Electron affinity or electron gain enthalpy. Electron affinity. Electron affinity or electron gain enthalpy. Gain enthalpy. Electron affinity or electron gain enthalpy. Remember, what is electron affinity or electron gain enthalpy discussing? It is energy released. Energy is released. Energy is released when electron is added to, remember students, when energy is released, when electron is added to, gaseous isolated neutral atom, isolated gaseous neutral atom. Remember students, for example, X gas taken now, X gas combined with electron, it converted to X gas minus ion. In this process energy is releasing, energy is releasing. This energy is called electron affinity or electron gain enthalpy. Electron affinity. Electron affinity or electron gain enthalpy. Remember students, when electron is added to isolated neutral atom, some amount of energy is releasing. This energy is called what? Electron affinity. If nuclear charge increases, electron gain enthalpy also increases. In generally, when nuclear charge increases, electron gain enthalpy increases. Electron gain enthalpy increases. Nuclear charge increases, electron gain enthalpy increases. So in generally what, down the group what, nuclear charge decrease, along the period from left to right nuclear charge is increased. So electron affinity or electron gain enthalpy from left to right in a period increase, from top to bottom in a groups what, electron gain enthalpy value decreases. Now that I am going to discussing now variation of what, electron affinity or electron gain enthalpy in group sign period, that I am going to discussing next concept. So generally this is a general definition given me. What is electron affinity or electron gain enthalpy? Simple, what, energy releasing when electron is added to atom. One electron is added to atom what here, that atom converted into in the form of what, anion. For example, X converted to X minus gas, whatever electron is added here, the some amount of energy is releasing by in this process, that energy releasing, that energy is called electron affinity or electron gain enthalpy. Variation of electron affinity, variation of electron affinity in group sign period, variation of electron affinity in group sign periods. Variation of electron affinity in group sign period. In a period, electron affinity, this is general concept I discussing by here. In exception cases also coming in this concept, but that much of deep we are not discussing here, just basics I am going to explaining. What is the basics for learning what 11th and 12th standard. Now, in a period electron affinity what increases. The reason what, in a period from left to right what, atomic size decreases. The reason, Z effective increases, and ionization energy what decreases, ionization energy increase, therefore electron affinity also increase in a period. Generally electron affinity also increase. Remember why electron affinity increase in a period? The reason what, from left to right what, radius decrease. Why radius decrease? Because of Z effective is nothing but nuclear charge increase. Once the nuclear charge increase means nuclear effect on outermost electron increase, the force of attraction increase in between what, nucleus and outermost electron, therefore ionization energy increase and electron affinity also increases. Now I am discussing in a group, electron affinity in a group, electron affinity what decreases. The reason what, in a group from top to bottom what, n value increase, therefore radius increase, Z effective mean effective nuclear charge what decrease. So ionization energy what decreases, therefore electron affinity also decreases. Remember students, here this is in a group given. In a group electron affinity decrease. Why electron affinity decrease I am giving here. In a group from top to bottom what, n value increase, principal quantum number, atomic size increase, nuclear charge decrease means nuclear effect on outermost electron, what decrease, therefore ionization energy what decrease, electron affinity also decreases in a group. Now fourth periodic property explaining now. that is called electronegativity. 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 So, electronegativity is nothing but it is a tendency of attraction of bond pair of electron, bond pair of an electron, bond pair of electron. It is a tendency of attraction of electron, bond pair of electron by an atom, in a covalent compound, This is called electronegativity. Electronegativity is nothing but tendency of attraction of electron density from bond towards what atom. It is called what? Electronegativity. Electronegativity is nothing but it is depend on Z effective. If nuclear charge increase, what? Tendency of attraction of electron density from bond also increase, therefore electronegativity increase. That is why tendency of attraction of bond pair of electron towards atom, it is called what? Electronegativity. Electronegativity depend on Z effective, nuclear charge. It is depends on nuclear charge, Z effective nuclear charge. It is depend on effective nuclear charge. If Z effective increase, what? Electronegativity also increase, because of tendency of attraction of electron density also increase. The tendency of attraction of bond pair of electron in bond is called what? Electronegativity given. It is depend on Z effective value. Nuclear charge increase, what? Attraction increase, therefore electronegativity increase. Generally what? In a group, what? Electronegativity decrease, along the period what? Electronegativity values increases. Now variation of electronegativity in group sign period. Variation of electronegativity of an atom in group sign periods. Variation of electronegativity in groups and periods. Variation of electronegativity in groups and period. Now first I am going to discussing in groups. In groups, what? Generally electronegativity what? Decrease from top to bottom. From top to bottom, what? Electronegativity decrease. The reason what? Atomic size increases, what? Ionization energy what? Decreases. Therefore Z effective nuclear effective also decrease. Therefore what? Electronegativity what? Decreases down the group. Remember students, this point you have to remember. General concept I am explaining, variation of electronegativity in group sign period. First of all I am discussing in a group. In a group from top to bottom, what? Electronegativity decrease. The reason radius what? Increase, ionization energy decrease, Z effective value decrease, therefore electronegativity what? Decrease from top to bottom in a group. Now let us discuss in period. In a period from left to right, electronegativity what? Increase. Reason, from left to right, you know already, from left to right what? Z effective increase, therefore ionization energy what? Increases, electron affinity also increases and electron negativity also increases. Highest electronegativity of elements in the long form of periodic table, what that is fluorine. Highest electronegativity of an atom in the long form of periodic table, that is fluorine. Highest electronegativity of an atom in the long form of periodic table. Highest electronegativity of elements in the long form of periodic table, that is called fluorine. Highest electronegativity of an atom in the long form of periodic table. The electronegativity of an atom is measured by using what? Scale, it is called Mullikan scale. Electronegativity is measured. Electronegativity of an element is measured by using what one scale, it is called Mullikan scale. Mullikan क्या है इधर साइंटिस्ट का नाम है भाई. Electronegativity of an element is calculated by using one scale, it is called Mullikan scale. See, according to Mullikan scale, how to calculate what electronegativity of an atom? General concept given, general scale given here. According to Mullikan scale, Mullikan scale, electronegativity of an atom is measured by using what? Electronegativity of an atom is calculating by using, it is the average of ionization energy and electron affinity of an atom. Average of ionization energy and electron affinity of an atom. I is nothing but ionization energy, ionization energy. Here E is nothing but electron affinity. Electron affinity of an atom. So, this is according to Mullikan scale, general what a formula given. By using this formula, we can calculate what electronegativity of an element, that is average of ionization energy and electron affinity. If IE, comma EA are taken in kilojoule per mole. If IE comma EA are taken in kilojoule per mole, this formula using for calculation of electronegativity, that is IE plus EA divided by here 544. Remember, when this formula is using by, if IE comma EA value is taken in what? In kilojoule per mole, in that case I am using what for calculation of electronegativity of atom, En is equal to IE plus EA by divided by what? 544. Second point giving now, if IE comma EA are taken in electron volt, then this formula using now electronegativity of an atom is calculating by using this formula ionization energy plus electron affinity divided by 5.6. When this formula is using by if IE and EA value is given in electron volts. If IE and EA values are given in electron volts, I am using this formula electronegativity of elements IE plus EA by 2 divided by 5.6. One more point giving third point, if IE comma EAR are taken in kilocalorie per mole. In question what? If IE and EA value is taken in a kilocalorie per mole, then you have to use this formula electronegativity of an atom equal to ionization energy plus electron affinity divided by what here 130 given. These three formulas remember it became useful in first PUC chapter. Remember students. Next periodic property, last, it is called electropositivity. 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 It is a tendency of loss of electron. The phenomenon is called electropositivity. Tendency of loss of electron. Loss of electron is called electropositivity. Electropositivity. Tendency of loss of electron is called electropositivity. Remember, in generally what down the group electropositivity character increase, along the period what electropositivity character decreases. In generally down the group electropositivity character increases because atomic size increases. Atomic size what increases already given, and nuclear effect on outermost electron. Nuclear effect on outermost electron what decreases. So electron easily losing, that is why the tendency of what loss of electron what increases. For example, I am taking sodium and cesium. Cesium easily losing electron. Sodium also losing electron converted to Na plus and electron. Cesium also losing electron, it converted to Cs plus and electron. Which atom easily losing electron? What is a cesium? That is why electropositivity character for cesium is more. Electropositivity character cesium greater than sodium. Because of down the group what atomic size increase, the nuclear effect on outermost electron decrease by electron easily losing atom, therefore positive character increases down the group. In a period from left to right, electropositivity character decreases. In a period from left to right, in a period from left to right, electropositivity character what here decrease. Reason what? From left to right, Z effective nuclear effect what increase on outermost electron, atomic size decrease, you know ionization energy what increase given, electron affinity also increase. The main important point what, why what electropositivity character what decreases from left to right in a period. The reason nuclear effect on outermost electron is more, therefore force of attraction is more from the nucleus and outermost electron. That is why the outermost electron not easily losing electron into outside, therefore what electropositivity character decrease in a period from left to right. See, after periodic properties, now let us discuss about what tetravalency of carbon. Tetravalency of carbon discussing now. Carbon have tetravalency, mean carbon have tetravalency. It's mean carbon attached to 4 bond, carbon attached with the 4 bonds, either single bond or double bond or triple bond, but 4 bonds. Why carbon what attached to 4 bond? Why carbon showing tetravalency? The reason, carbon atomic number Z is equal to 6, the electron configuration 1s2 what 1s2, 2s2, 2p what 2. In outermost shell electron configuration is observed, this is called outermost shell electron configuration. Outermost electron configuration. In outermost electron configuration, electrons are called, these are called valency electron. Valency electron. In outermost electron configuration, once you observe, there are 4 electrons are there. The 4 electrons are octet incomplete. To complete the octet, 4 electrons are required. That is why carbon always attached to 4 bonds. Why carbon attached to 4 bonds? The reason, so due to absence of 4 electron in outermost shell, to complete octet 4 electrons are required, because of only 4 electrons are there in outermost shell. There are 4 electrons are required to complete octet in outermost shell. That is why valency of carbon here 4 taken here. The reason, to complete octet, to complete octet in outermost shell, in outermost shell of carbon, in outermost shell of carbon, there are 4 electrons required. There are 4 electrons. 4 electrons are required. Hence the valency of carbon is taken as 4. That's why in organic compounds, in hydrocarbon, carbon always attached to what? 4 bond, either double bond or triple bond, but carbon always attached to what? 4 bond, like that, either double bond or single bond, carbon always attached to 4 bond, like this, C double bond C, like that taking now. Carbon always attached to 4 bond, either double bond or triple bond, but carbon always it is attached to what? 4 bond. That is why carbon valency, carbon is valency is taken here tetra valency. The reason what to complete octet in outermost shell there are 4 electrons are required, that is why carbon valency is taken as 4. Compounds of carbon, compounds of carbon, compounds of carbon. First I am going to discussing hydrocarbon, hydrocarbon. What are hydrocarbon discussing now? Compound which contain carbon and hydrogen, compounds which contain carbon and hydrogen, carbon and hydrogen are called hydrocarbons, hydrocarbon. Compound which contain carbon and hydrogens are called hydrocarbon. Example for hydrocarbon: alkane, alkane, alkene, alkene, alkyne, alkyne and aromatic hydrocarbons, aromatic hydrocarbon. So these are called hydrocarbons by, remember here what are hydrocarbon definition given: compound which contain carbon and hydrogen only, they are called hydrocarbon. Example for hydrocarbon: alkane, alkene, alkyne and aromatic hydrocarbon. So these are called hydrocarbons. Next class we will discuss better now about what are hydrocarbons, what are alkanes, what are alkene, what are alkyne and aromatic hydrocarbons. We will continue from next class. Thank you, my dear students.